Hello, I'm Moreton, and I'm here to talk to you today about apparently introducing the testing diamond. Who here is expecting a testing talk with the classic kind of pyramid thing on it and that kind of thing? Anyone? Yeah? I promise you no pictures, it's all good. Ice cream cone maybe? A little bit of fluff? No? Okay. So I work currently as a principal dev over at the Ministry of Justice, more specifically the Office of the Public Guardian. What we do is look after lasting powers of attorney, so altruistically good. Hooray! Not many people get to say that. Yeah. All right. Okay, so by way of introduction, I know that testing is a super highly opinionated space. I'm not really here to peddle my particular opinion. I'm more going to address some of the broader concerns and get you to think more, hopefully, about trade-offs when you come to choosing the type of tests that you're going to pick, and hopefully be a little bit less hung up on what each individual word means, because that's a road to hell right there. Okay, so just quick gauge of interest. Who here really enjoys like a TDD approach to writing code? Cool, rock on. Who enjoys spec flow and writing stuff in kind of a BDD style format? Yeah, some, that's cool. I'm not going to mention any kind of implementation of how you do this stuff, so just whichever way you do it, that's up to you. Yeah, we're going to talk about kind of overall how you pin the different types of tests together to have a sustainable strategy. And the other thing that I would hopefully you go away with from this talk is a sense that the most important thing you can do, other than weaving some maintainable strategies, is part of that is building it into the sense of community in your local teams and businesses, because ultimately the only way to sustain testing effort is making it a cultural thing. I won't go over it in a lot of detail, but please keep that in mind. So the plan. I always like to start with the value of what I'm doing. So here we're going to talk about what is the value that I'm actually expecting to deliver with automated tests. So we'll kind of treat this as a product type exercise maybe, or at least that kind of view. So you would be able to engage with any other stakeholder in your team and talk about kind of what is the value of what I'm trying to achieve. We'll then move on to talking about the language. This isn't to establish my opinion about what the words mean. It's more just to establish, in a very short space, the DDD equivalent of some ubiquitous language so that we're all thinking and talking about the same things, at least for the duration of this talk. If you go away and have completely different uses for these words, that's fine. Use them however you wish, but I need to establish a common dialogue just for this talk. And then lastly, we'll move on to strategy and how you weave these things together to form overall coherent and maintainable strategies for testing. And we'll just look at one or two micro examples. If you have broader questions, I really welcome them, particularly at the end, but also after the talk, I'll be going down to floor 2 and sitting at a table for a while. And if you want to come and just talk, that's cool. I won't bite. Okay, so we will start with value. Excuse me. So, testing as a product. This is actually one of my favorite exercises to run through when I start up a community or something like that, a community of practice, is what is the value that we're trying to achieve? To treat it almost like a mini design sprint. You think about your personas and your actors and you talk about what are these stakeholders expecting of us, of our contract with them. But in this case, we're talking about testing. So fundamentally, what do we want out of the tests? And most commonly, I think James Shaw touches on this a little bit in some of his blogs, but we want to establish confidence that the software under test works the way that we expect it to. We want to be able to document the behavior of that application under test so that we can clearly then, or hopefully any member joining the team can then very quickly get up to speed with that product. and we want to introduce a really solid, tight feedback loop. And those are really the tenets that we're trying to achieve. Yeah. And when I say tight, that isn't obviously the only thing that gives feedback value. There are other aspects to these things, but I'm going to focus on just a few of the aspects and connotations of these things. I might explain some of the broader terms, but we're going to focus on just a few bits because of time. So inverting the idea of thinking about testing as a product is usually one of the exercises. What are the main risks to our value? What are the things that erode the mission? And one of the key things for eroding the value of your test suite, if you're looking at confidence, is unreliable or flaky tests. There's nothing faster than, okay, another quick poll. Has anybody here worked in a place, it's okay, you don't have to give it away, but where you've had a suite which is in the pipeline somewhere and you run it maybe 3 times just to get the test passing? Yeah. What's your confidence level that the code actually works after that process? Next to 0? Yeah, that would be correct. Yeah, so confidence, if you're not achieving that, that's a problem. Documentation. This will get interesting on the next slide, but one of the key things for documentation is, say, when you look at documentation for anything else in the public domain, is there stuff missing from the documentation? Can you find out how to do the things that you expect to do? So a nice way of thinking about documentation is, well, testing documentation is, are there any gaps? Will I know how this thing behaves? Will I be able to find out? And feedback, other than kind of going for measurable things here, which you'll see why in a moment, but one of the key things for feedback is its speed. If you have to wait an hour to find out if your tests still pass, that's an hour of you maybe going and making a cup of coffee for an hour. I guess it's possible these days. Does anybody grind their own beans and that kind of thing? No? Yeah, well, excellent. But possibly not the most productive use of your time. Anyway, gratification here in tight loops and being able to see the results of your work quickly, I think we're all sold. Other things in feedback can be like the quality of the feedback that you get, so whether there's adequate tracing or something like that of what's going on in your tests so that you can understand how to fix a problem if it arises. I'll touch that again in a sec. And this comes back to transparency, but so we've established kind of the mission that we want to achieve in terms of value. We've talked about some of the key risks. And to make this really transparent to the other people that you work with, because transparency is power, even if it's a vulnerable thing to do, is to basically provide an interface or a common set of numbers that somebody else can also understand. And you can link it back to the value that you say you're delivering. So for example, with confidence, you could measure the regularity with which some tests fail. So if you have some tests that fail on a regular basis and you're keeping track of the error counts of those things, it's a pretty good call to action to say these tests fail a lot, maybe we should have a ticket. Or looking at documentation, coverage. Now, I put ish. Just again, out of interest, does anybody have a coverage target that they punch for? Okay. I'm on the fence. I'm Switzerland. No. This can be a tool for good and a tool for bad. It depends how you wield it, like every tool. So coverage, how many forks through my given code base am I covering with tests? Coverage, in this case, is more of a gauge of how much documentation is there. How much of the product can I show how it works? Particularly if you've inherited an existing pre-loved system. Yes, I saw that. Excellent work. An existing pre-loved system, then it's not going to have wonderful coverage, most likely. And then you might want to take a risk-based approach to introducing testing. When I say risk-based, I mean what are the areas where we're most likely to have to introduce change? What areas have caused us the most issues historically? You could look at bug reports, you could talk to your support team if you have that kind of facility. Which areas have the highest churn, which areas have the highest complexity. All those are good indicators, but in terms of measuring value of the suite and how it's delivering, coverage gives you a rough indication of how much documentation there is. It shouldn't ever, ideally, in my experience, be used as a hammer because it might encourage bad behavior. So has anybody ever seen any code where somebody's punching for higher coverage? So what they've done is invert this problem and just write a load of nonsense tautology code. Sorry, a truism. So a path that is always correct. And then write a load of tests that cover the nonsense bit just to make the bit above it pass the coverage statistic. I know that, I've seen that. That's okay. It's not okay. Don't do that. It can encourage gamification and poor behavior. It also can be the case that for certain kinds of coverage, it can be difficult to achieve under certain circumstances, but setting a hard and fast goal, all these things are local context sensitive. So if you saw Sam Newman's talk about tear it up and start again, I'd say this is one of the things where you want some global consistency maybe in the things that you measure, but you want some local consistency about what your targets are, or your service level objectives, I guess, but what your targets are for those measures. For some teams, it'll make sense to punch for more coverage or faster execution runs or less tolerance around test failure. For other teams, it's important to be local context sensitive, to be forgiving, and maybe punch for better targets over time. Next up, feedback. The key obvious thing here is time. I think the rough rule of thumb that I've seen a lot of teams adopt is if it takes longer than just going and quickly grabbing a drink, so 5 minutes, then it's probably taking too long to run the whole suite, whatever that suite is. And the last aspect I wanted to touch on was the idea of delta. So you can apply each of these, well, particularly the coverage and time metrics to the whole time a test suite takes to execute, or the coverage of a whole suite. But by delta here, I mean the delta introduced by a single pull request. That can be really powerful and interesting, because if, say, somebody raises a pull request and all of a sudden your tests take 3-4 times longer to run, that's a big call to action. Maybe that pull request shouldn't get through. Or likewise, if your coverage takes like a absolute nosedive, that's a really interesting thing. Maybe talk about it. And it can also encourage good Boy Scouting, like we maintain at least this level of thing per delta. So we've covered value. Next up, I'm going to establish some common language. This is contentious, I know. Okay. So I'm only going to introduce a few testing terms, and this will just be to cover the 2 examples that I'm going to cover. This isn't going to be the whole gamut of potential types of tests that you can write. We'd still be here when the party in PubConf is like happening. Go to PubConf, it's great. So we're not going to do that. So for UI end-to-end testing, what I'm really talking about here is your Selenium style or Cypress thing that's maybe crawling a page, looking at CSS selectors, clicking buttons. The underlying stuff, I'm really talking about having a real kind of stack there where possible. You might have variations there for time and speed and reliability compromises. That's all cool. But in this particular example, it's using as many real moving parts as possible. The value per test is an interesting thing to talk about. So the value of a UI test, if you think back to the things that we were trying to achieve earlier, the confidence delivered by a working UI test is incredibly high because it exercises a lot of your stack, a lot of logic, a lot of things. But the trade-off here is that in terms of feedback, they're known to be slow. Like it's a problem that's incredibly difficult to get around. So if we're looking at our metrics, there's a trade-off there. And likewise, they're famously brittle for a variety of reasons. You can be very careful about how you write this kind of thing and achieve stable tests to a degree, but the ongoing kind of maintenance effort there is high, is very high. So that gives you kind of a flavor of what the trade-offs are for a UI test and how we might want to think about it when we're developing an overall strategy. And I've included a little note here about where, because I got some feedback, fortunately, before I made a fool of myself in front of everybody, but I want to be clear about where I ran these tests in my cycle. So for me, I try and say that any automated test, where at all possible, should be runnable locally. So you can get feedback. So again, going back to the values, we get the feedback instantly, or as close to instantly as we can. And the further right it gets pushed, the worse the value is delivered by that suite. If we have to wait all the way for it to be like deployed on some environment XYZ and something to be run over it there, that's potentially quite a long time. I know that can require quite a bit of engineering effort, but I think it's honestly the trade-offs for that are extremely worth it. Next down the stack, yeah, okay. So I'm assuming here a SPA of some description. Maybe it's a micro front end. I don't know. Maybe it's got, I don't know, Vue.js or something. But a component test was probably a thing that rose with the rise of Angular. But it is the idea of testing a single UI component. And in its modern form, probably came up with the SPA generation. And it's quite nice. It put the isolation here, because you talk about isolation a lot with tests, here being you're isolating the concerns of the thing under test to just be that thing. And the isolation here is around the idea of a component. I know this isn't probably news to a lot of you, but we're going to just cover the terms so that everybody's on the same page. And the beauty of these tests is that they are run in isolation, but they can provide a fair bit more value than the definition of a unit test we'll see in a minute, because they cover the whole interaction and contract that that component has with the other elements of the UI. And that provides a fair amount of value, not as much obviously as a full-on UI test, but the benefit here, the trade-off here, is that the feedback cycle much, much shorter, and the determinism, how regularly you can put the same inputs and get the same outputs out of that type of test is much better. So your results can be deterministic based on some inputs, and that's a really powerful place to be. And again, where preferably on the machine, on your local machine, and subsequently through the pipe. Unit tests. Do we have any mockists in the room? Who really likes mocking out every single dependency? A few. It's not a shameful thing. It's no judgment, safe zone. Safe zone, no judgment. It's important to actually have all these discussions with your teams. There's no bad answers, there's just trade-offs. It's really easy to stand on a particular soapbox in terms of which type of testing you like, but unless you can bring that back to the value that you're trying to deliver, then it's kind of a moot point. So here, for the purposes of this, we'll assume that it's a proper full-on mockist style where every external dependency of this unit is mocked out, faked out. You got fake behavior in everything apart from the isolated unit under test. Now, the value per test here, value is at its lowest compared to the other tests because it proves the least in terms of coverage of your whole code base. It's a tiny slice of functionality by definition. But that gives you power because obviously the feedback loop is the shortest because it's super, super quick. And the reliability of that test should basically be unbreakable because there's almost no moving parts. It's just the thing under test. And again, where on the machine, You'll just hear me say that for everything. Now we're moving to stuff that's more back-endy, purposefully for the examples. I'm going to start off with API integration tests. Who's fortunate enough to work in a workplace where they already do something like contract-based testing with consumer-driven contracts? Oof, only a couple. Well, you're in a very fortunate space. For the intents and purposes of this, we're going to go with a provider-driven contract. And here, what I mean by that, in case this is assumed knowledge, what I mean is the API or the application under test knows about its contract and provides that contract to interested parties. A typical example could be a public-facing API where the documentation is pretty much set in stone because you don't know what your consumers necessarily are really doing with your API. And as anybody who's ever looked after a public-facing API knows, that it's hell on earth to change the contract. And if you change the contract, you're going to really, really make some people angry So you want to know that that works. But in this case, provider-driven contract. How you achieve this, we'll also say that it's a black box style test. What I mean by that is there's a running process, your application, you're going to hit it with some HTTP, a GET or a POST or whatever the thing under test is, and you're going to get back a HTTP response. You might also look at some of the side effects, so an update to a database, something getting put on a queue somewhere, all those kinds of things. But you won't touch the inner workings of the application. There is white box testing as well, but for this purpose, we'll go with black box. And again, value per test. Here you've got quite a lot of real moving things. I think if we're talking about feedback, another trade-off to think about is how many moving real parts. So say the classic argument is, do you use a real database or not? Now, if you want the thing to be as real to life as possible and get the most value out of the test, yes, use a real database. If you're having problems with performance, that should be an indicator for a whole other gamut of things that you might want to think about in your non-functional requirements. But if that's a trade-off where you're already meeting your non-functional requirements, this is okay for your customers, and you are having performance issues with your tests, then you might think about mocking out certain aspects of your tests. But try and use real things probably at this kind of level. So the value per test here is, again, really high because it proves a lot, it exercises a lot of the stack, gives you a lot of confidence that this is going to be the experience that customers get out of your tests. But the trade-off can be speed, although, for example, I've worked in places where there's more than 10,000 tests of this type on a single API, and they can run in just 2 or 3 minutes as a whole suite. So it's very achievable to have really powerful, fast tests, especially at this kind of level. And the other trade-off can be feedback. So, but again, this is an interesting exercise. So obviously, when you execute this kind of test, to get feedback about the actual execution of the underlying process and what's going on, and if it doesn't work, why, this is the closest you'll get to debugging a live issue. This is the point where you need to know that your logging's working the way you expect. That's a pretty valuable experience to me. You can tell what my preferences are. Again, run these early. Left shift it as much as possible. Stick it on your machine, if at all possible, and then in your CI pipe at the very latest, but try and get them running. And then a couple of things that are not specifically implementation focused. So I know there's some different opinions again on smoke tests, but I guess I'll start with the objectives, in fact, on this rather than going for the definition straight away so that we demonstrate value. But the objective of a smoke test for me is to prove that the artifact that you're deploying somewhere is running and it's configured correctly, things like that. It's not to test the functionality, it's aliveness, effectively. You can achieve that through monitoring and some other things, but Depends how mature your approach is to risk in an organization. I mean, let's face it, we're all doing live testing in prod all the time, because all automated testing does is help us establish confidence that we think it works. And then we deploy it. And then hopefully it does work. But yeah, so none of this replaces, in fact, it just enhances the experience. But you should always have monitoring, of course, continuous monitoring and all those good things. But look at Jess White's material for some of that. So that's the objective of the smoke test, proving that it works. So the definition here is something that, a suite that exercises every dependency a deployable artifact has at least once. They'll check that your configuration is correct for any databases, any third-party services, say it has a reliance on S3 or something. Just checks that it can talk to the rest of the things that you expect it to be able to talk to. And where? This is the deviant. So where this will be run only when something is deployed to a fresh environment. You might also make these runnable locally so that you can add to the smoke test. Say you introduce a new dependency to your service or your application. It's quite nice to get that into the dev lifecycle so that you don't have to wait for a deployment to know that your smoke tests still work. But yeah, that's about where it stops. I wouldn't expect you to run these as like locally. That wouldn't, all the time. That wouldn't make a lot of sense. And when it comes to implementation, I try to keep these above implementation detail, but when it comes to implementation, I'd expect it for a front-end based application, say you're going all the way to the micro front-end thing, then you'd expect some kind of, maybe some UI tests. I'm hesitant to say UI tests because it gives you a certain thing, a certain feeling that it's going to be a whole journey and all that kind of thing. But no, all I'm really interested in is you hitting every dependency once. So if you've outsourced the idea of identity to OAuth, some OAuth provider or something like that, you might have a flow that uses that third-party service once. Just to prove that it's configured correctly, you've not somehow jabbed in the wrong public key for something in some system, whether that's a HKM store or something like that. Okay. Then the lovely idea of acceptance. We all accept that this story is as we say it is, you know. Has anybody ever had a separate acceptance test suite? Yeah, I call that out as an anti-pattern, really. It's a bit weird. Just because, for me, the idea of acceptance isn't just tests. It's the whole team achieving acceptance of that story for a start. And in testing terms, the nicest analogy I've seen is the Swiss cheese analogy. There was a blog 7 days ago published by somebody called Corny who works for ThoughtWorks, but they talk about the Swiss cheese model. And the analogy here is every layer of tests that you have is effectively a slice of Swiss cheese with all the holes in it. And as you layer these slices of cheese together, ultimately you're going to get to a point where hopefully there's not many holes of light going all the way through the block of cheese. And then you know that you've covered pretty much most of the scenarios that is expected in terms of behavior of your software. And that helps you achieve acceptance. I thought that was a really nice analogy, so I stole it. But I'm giving credit, so it's okay. Yeah, like any good university student. Not that I even have a degree. Anyway, so achieved across layers. So next up we will talk about strategy. So for our first example, we will have a micro front-end SPA bleeding edge, like tiny application. Let's say it deals with just, I don't know, search on your website. It's not really important what this is. And you would expect to see, does this work? Yeah. You would expect to see just these tests, maybe, for the argument of our definitions earlier. Rather than saying just these tests, we'll talk a little bit now about some of the trade-offs earlier and the kind of blend of tests that you might expect to see, so that we can have more of a discourse on why you would choose certain amounts of tests where and why. So with the UI tests, for example, going by our earlier definition, we know that these deliver a lot of value, but they come with quite a lot of cost. So by that definition, you want some, but not too many. So for the purposes of this really tiny application, what you can probably say is that you can still keep that fast and cover maybe all the happy path journeys. That might be sufficient. You might still get the execution time out of it that you need and deliver the value. Exactly what your execution targets are with your team. Let's say in this case, 5 minutes is the maximum we'll accept for a suite run, just out of argument's sake. So your goal is to make sure that this suite can run in under that time. And obviously try and parallelize the suite runs so you're not waiting forever for everything. Component tests. These were quite nice. They proved quite a lot, but they did do it in isolation and they were much more reliable. So maybe in this case, the bulk of our testing will probably be in the component tests because it comes with the least negative trade-offs. We get a lot of surety, a lot of confidence, and less of the downsides. And then unit testing. Interesting. What would you expect to unit test in this scenario? Maybe it's some core logic that's shared across multiple components. Maybe something like that. There is an argument to say just use the concrete implementation in the component tests, and then you almost have a consumer-driven contract for the internal, the internal application logic. But you also might want to isolate that functionality and provide a contract to the potential consumers, and you prove reliably that that works the way you expect. And then lastly, smoke tests, just to, again, go over it once, make sure it's alive, make sure it's okay. In this particular setup, probably a couple of UI tests, just to check the dependencies. Don't check the logic. You've already proved that you've accepted the story by this point. It's okay. We can move on to the land where we're just checking that in this environment we've not done goofed. Who here's released something and realized that you don't have the right SSL certificate? Yeah, brand new API, nobody can get to it. Excellent. Anyway. The second example would be more of a back-end thing. So for the purpose of this argument, we'll say it's a public-facing HTTP API that happens to be running as a microservice. I went for public-facing because you don't know who the consumers are necessarily or how they're consuming your API, which is always a bag of fun. Now, here, somewhat controversially maybe, I expect possibly almost all the testing to occur in the integration layer because you can get those tests running really quickly, really reliably, and they provide a lot of value. They also help you know that you can diagnose issues if there are any issues, when there are issues in your production environments. You get a lot of value out of those tests. And I'm pretty convinced that in almost all cases, barring maybe some where you've got some really expensive dependencies, you can get those tests running really quickly. Or you should be able to, because that is the contract you have with the public at the end of the day. And if you can't get your endpoints running at a reasonable pace, then that's the experience your customers have of using your APIs. That's not a good thing. Then unit tests come in, and they do have value. So some examples of some things which break the rule of integration testing there would be if you want to prove, say, if a database node goes offline, what the hell the behavior is. If you want to set up an environment and knock out nodes and things as part of your test suite, like that's really cool, but you'll be there a while. And getting those tests to a point where they're really reliable it's not a good trade-off. So writing that into some unit tests will provide a lot of value. Those unit tests here were from our definition earlier, so you might want to write them at the various levels where you expect some kind of different behavior. Maybe you're returning 503s now instead of something else. And then smoke tests again, just to prove the aliveness. That brings me on to coupling. So, coupling. When you introduce tests, you introduce coupling. You say, I have this contract and I'm proving that it works the way I expect. That is a really high piece of cohesion and coupling right there. So much like when you're thinking about your microservices maybe, and you're thinking about where the boundaries are and what coupling do I want and where, so the same should be true for tests, because you ideally want these contracts to be stable, because that means that you don't have to rewrite the tests all the time. It means that you're getting the biggest bang for your buck. Particularly the HTTP API that we're talking about is a wonderful example, because you have these really stable contracts with public parties or with other teams, and you don't want to change them willy-nilly, because you'll just upset a lot of people. And that is an ideal point for coupling, because you have that stability. In the UI land, you're kind of screwed, to put it politely. I don't think I've ever seen a UI that's remained stable forever, so unlucky. But yeah, just look for points where you know that there's good stability. That can be another discussion that you can have, because that will lead you down a path where you don't want to kill yourself every time you have to make a change to the piece of software that's covered with all these lovely tests. So say somebody I used to work with used to really like test-driven development, and I do too, but he proposed that maybe after top-down test driving his feature, he was just going to delete all the unit tests that were already covered further up. That was his compromise. This is something to just talk about. There's always trade-offs, always trade-offs. So if you can bring it back to the value that you're trying to deliver, the feedback, the documentation, the confidence, every single time, that's when you're going to get the right results. And just making it a safe place where anybody can talk about testing. I know it's a heated thing, but there's no one correct answer. And because it was in the title, and because I wrote the talk after I wrote the title and thought, okay. I didn't also want to put a picture, but if you imagine here, we're deleting out a chunk of the unit tests. You kind of cut off the bottom of the pyramid and turn it into a lovely diamond shape. But I hated myself too much to put it on here. I just couldn't do it. I couldn't do it, so I'm sorry, but imagine the diamond. It's staring at you. Okay. I'm just going to reiterate it once more for emphasis. This is a sea of gray. Unfortunately, that's life. There is no correct one approach, one hammer to hit every nail with. You have to build a tool set. And part of that tool set is your team, and having those healthy conversations with the team about what all the words mean, what the value is you're trying to represent. It kind of comes into the Google SRE book as well, which is lovely, about establishing some common measures. If you all have a preset set of measures that you know you're punching to hit or that you can talk about, that's some common language established right there. You can talk ubiquitously about these kinds of things, and it helps diffuse it. It helps turn it into a healthy discussion about us all achieving the best job, rather than somebody really likes this type of testing. So to recap, we didn't cover a bunch of stuff. That's semi-deliberate, because I don't want to keep you here all day. But accessibility, performance, security, infra, continuous monitoring, everything. There is a lot to testing of various different types. Please do it all. Where at all possible, do it in the features. Keep it as close and tightly coupled and left-shifted, as left-shifted as possible. Do it on the machine, do it early stages of your pipeline, wherever you can. There are some exceptions to the rule, but wherever you can, left shift. And in summary, we started with the value. We talked about the three tenets of what I think produce value in tests. The one kind of missing one was maintainability. It's kind of inferred, but in case, you want to make sure that your tests are also maintainable at the end of the day. We established a common dialogue about some of the words. We went through a couple of examples of trade-offs and strategies. And we just basically talked about the whole thing being a sea of grey, and I'm not any help to you. All right. For resources, there are some really good blogs with a lot of history. James Shaw, Goiko, Jess for the continuous monitoring, Corny I mentioned with the lovely Swiss cheese example, and your peers, the people sat next to you right now. They will have opinions. They came to this talk. I'm sure you can have really interesting discussion. And me, I'm downstairs, floor 2, after this. And plugging it again, PubConf. It is a lot of fun. It's not an NDC-run event, but by people who are, well, speaking at the conference, it's fair to say. And it's a lot of fun. 5-minute Ignite talks, people make, well, fools themselves really, or try to, and just have fun doing it. No cameras, no videos. It's a closed doors kind of event so that people can talk, just let their hair down and say just funny stuff without fear of their company sacking them. And then I'm a co-founder and co-organizer of another DDD conference. For those uningratiated, it's the developers umbrella of conferences. They're all free or near free, nominal fee. Ours is completely free. It's run in the Midlands, October 3rd. Oh, there it is. Okay. It's public submission. Anyone here could speak. And it's anonymous vote. So anybody attending the conference can vote on the topics they want to see. And your submission, as in your face, your name, are not shown. It's only the titles and the abstracts. So you'll have a pretty damn good chance of getting in. And we offer a lot of support for first-time speakers and video recordings and things, so you can more easily get to events like this. Okay. Lastly, thank you very much. Hopefully forgive the subliminal messaging right there. But do I have any questions as well from anybody? No? Okay, then I'm on floor 2 afterwards. Come and find me. Thank you very much.